Hello and welcome to this session, Learning Outcome, LO2, Know How to Perform Engineering Calculations. Today, we will dive into the fascinating world of engineering principles. Are you ready to explore? In this session, we'll guide you through essential calculations and concepts, from achieving numerical accuracy to understanding forces and their effects. Let's uncover these critical topics and strengthen your engineering skills. 0203-0405. Understanding numerical accuracy is crucial in engineering. It defines the precision of measurements or calculations. Expressing values correctly ensures reliability. For instance, rounding to significant figures or decimal places. This accuracy reflects the true value being measured. This is bullet point 1. When expressing values to three significant figures, keep the first three non-zero digits. Zeros may be used as placeholders. For example, a result of 25.45321 becomes 25.5. This precision is essential for accurate representation. It ensures consistency in engineering calculations. Expressing values to two decimal places involves rounding. Keep two digits after the decimal point. For example, 13.98765 becomes 13.99. This method enhances clarity in measurements. It provides a straightforward representation of values. Standard form or scientific notation expresses large or small numbers concisely. It uses powers of 10 for simplicity. For instance, 0.0000523 becomes 5.23 times 10 to the power of -5. This method simplifies complex calculations. It's widely used in scientific and engineering fields. In engineering, tolerance defines allowable variations. It's expressed as limits to maintain standards. For example, a diameter of 25 millimeters with a tolerance of plus or minus 0.02 millimeters. This ensures parts fit and function correctly. Tolerance is vital for quality and precision. Algebraic expressions represent quantities using variables and operations. They illustrate relationships between values. For example, x equals a plus b, y equals c minus d. Applying BODMAS ensures correct order of operations. This foundational skill is essential in engineering calculations. The principle of moments is crucial for rotational equilibrium. It states that clockwise moments equal anti-clockwise moments. This balance ensures stability in structures. Understanding torque, or rotational force, is essential. Torque depends on force magnitude, distance, and angle. Torque is calculated as force times perpendicular distance times cosine of the angle. It's measured in Newton meters. For example, a 50 Newton force at 0.1 meters with a 30-degree angle. Torque is approximately 4.33 Newton meters. This calculation is vital in engineering applications. Work, power, and energy are fundamental concepts. Work is energy transferred when a force displaces an object. Power is the rate of work done, measured in watts. Energy is the capacity to do work, existing in various forms. Understanding these concepts is essential in engineering. Work is calculated as force times displacement times cosine of the angle. It's measured in joules. For example, a 30 Newton force moving an object 5 meters. The work done is 150 joules. This concept is crucial for understanding energy transfer. Power is work done divided by time. It's measured in watts. For example, 200 joules of work done in 10 seconds. The power is 20 watts. Understanding power helps in evaluating energy efficiency. Energy is calculated as power times time. It's measured in joules. For example, 5,000 watts for 2 minutes. The energy is 600,000 joules. This calculation is vital for determining energy consumption. Friction opposes motion between surfaces in contact. It arises from surface irregularities. There are two types, static and kinetic. Static friction prevents motion, while kinetic friction opposes moving objects. Understanding friction is crucial for solving related problems. Friction can be reduced using lubrication or smoothing surfaces. Rolling instead of sliding decreases friction. Streamlining shapes reduces air resistance. Selecting low-friction materials also helps. These methods improve efficiency in engineering applications. Frictional force is calculated as coefficient of friction times normal force. For example, a box weighing 50 newtons on a surface with a coefficient of 0.3. The frictional force is 15 newtons. This calculation is essential for understanding motion resistance. Thermal expansion describes how materials change length with temperature. Heating increases particle movement, causing expansion. Cooling reduces movement, leading to contraction. The coefficient of thermal expansion quantifies this change. It's crucial for understanding material behavior under temperature changes. Linear expansion occurs in one dimension. It's calculated using the coefficient of linear expansion. For example, a rod expanding in length with temperature change. This concept helps in designing structures exposed to temperature variations. Accurate calculations prevent structural damage. Heat is energy transferred due to temperature differences. It flows from hot to cold objects. Specific heat capacity measures the energy needed to change temperature. Latent heat refers to energy for state changes without temperature change. Understanding heat is crucial in engineering applications. Specific heat capacity is the energy needed to raise a unit mass by 1 degree. It's calculated using mass, specific heat, and temperature change. For example, heating water requires significant energy. This concept is vital for thermal management in engineering. Accurate calculations ensure efficient energy use. Latent heat is energy for changing states without temperature change. It's measured during fusion or evaporation. For example, melting ice requires latent heat of fusion. Understanding this concept aids in designing thermal systems. It ensures efficient energy use in phase transitions. In conclusion, we've explored key engineering principles and calculations. From ensuring numerical accuracy to understanding forces and heat transfer, these concepts are fundamental. Mastering them is essential for success in any engineering application. If anything is unclear or you need more information, contact us at 0748-436-1688. We're here to help. Thank you for your time and see you at the next session.